Okay. Any answer in probability is a fraction. Okay. Any answer in probability is always a fraction. So let me just give you this scenario. What's the probability I choose somebody right now that's got blonde hair in here? Okay. What's the probability? First, on the bottom of any probability question goes the total number I'm selecting from. All right. So right now there's 19 of you in here. So my bottom on here would be 19. Right. That's the total you're choosing from. Now, remember, my question was, what's the probability I pick somebody with blonde hair? Now I count up the people with blonde hair, and that number goes on top. Okay? So it's the number that's happening over the total. Okay? That's always my total in the denominator. Okay, everybody good? I just want to make sure we're all clear. We're not going to have any negative answers in this unit. Probability cannot be negative. Never, never negative. All right? Real quick. You could have a probability of 0. You guys know a deck of cards? Familiar with the deck of cards? I don't know if anybody plays cards still anymore. Are you familiar with the deck of cards? If I said, what's the probability I pick a blue card out? There's no shot, right? That would be a probability of 0. All right, impossible of happening. Impossible. You could also have a probability of 1, which would be, everyone familiar with the 6-sided die? So what's the probability I roll a number less than 7? It's going to happen. All right, so that's a probability of 1. So anywhere between 0 is impossible. 1 is, it's definitely going to, without a shadow of a doubt, it's definitely going to happen. But we're going to talk about anything in between. All right, anything in between. So let's hop right into it here. Here's my first scenario. I got a spinner with 6 equal sections. Okay, a spinner, 6 equal sections. And what I'm asking for right here, what's the probability that the spinner lands on a 4? Okay, what's the probability a spinner lands on the 4? Before I answer that question with you, we probably will not write out everything in the question. We're going to use symbols. So does everyone see the P here? That stands for probability. Okay, that stands for probability. And inside the parenthesis is what we're finding the probability of. So that's why you see a 4. So instead of me asking you all the time, hey, what's the probability a spinner lands on a 4? I'm just going to write P4. P for probability. The 4, it says, what's it land on a 4? All right, so it's going to be a fraction. On the bottom is all your choices. How many choices are on this spinner right now? How many choices do I have here on the spinner? Grayson, good talk. Wes, how many options? I have 6. 6 options. And out of those 6 options, how many are a 4? I'm not trying to blow anybody's minds here. Gabriella, how many are a 4? Just one of them right there. So the probability of spinning a 4 is a 1 out of 6 chance. 1 out of 6. We're going to leave it as a fraction, but you could go to your calculator and do 1 divided by 6 and write it as a decimal, multiply it by 100 and give a percent. Probability can be fraction, decimal, or percent. We're going to stick with fraction though. Everyone all right on that basic one? All right, let's get a little bit more crazy. What's the probability it will not land on a 4? It will not land on a 4 now. Okay, so the probability not a 4. All right, how many choices do I have? Because that always goes on the bottom. How many choices in this spinner, Kaylee? Still 6, yep, still 6 choices. Now on top, how many are not a 4? All right, on top goes how many not a 4? How many choices are not a 4 up here, Julia? 5 choices. Good. I got stumped there for a second. 5 out of 6. No issues yet, right? That's basic. All right, now it gets slightly more complicated. Same spinner. What's the probability? It's greater than 3 and even. So both have to happen. It's got to be greater than 3 and even at the same time. How many choices do I have? Here we go. How many choices do I have, Henry?
2.
No. Total choices, 6. All right, so it's got to be greater than 3 and even. So I'm going to go through my choices right now. You tell me if they count or not. Can I count 1? No. 2? No. 3? 4?
Yes.
Greater than 3 and even. How about 5?
No.
Nope. 6. Okay, so how many of them were there?
2.
2 out of 6. Do I care? Here's the. Hey, Do I care if it's simplified? No, but just be aware some multiple choice questions may have it simplified. So you can have 2/6 or 1/3. I don't care which one you have, but just be aware some multiple choice questions we'll be answering probably be in simplest form. All right, anything right now? I know this is going quick, but now I'm going to slow down because now this is where I lose kids. This is in the next couple. All right, probability of getting a number that is even or greater. Now I took the and I replaced it with an or here. So it's got to be even or it can be greater than 3. Everyone agree? Still out of 6. Still out of 6. All right, let's go through right now. It can be even. So everybody ready? It could be 2, 4, 6. Good so far. All right. Or it could be greater than 3. Oh, can't count it again. I've already counted 4. I can't count a number a second time. Everyone good? I don't count it a second time. All right, let's keep going. Can I count 5? Yep. 6 already counted 4. I don't count it again. So it's not like I go 1, 2, 3, 4, 5, 6. You do not count the same thing twice. So how many total values do I have up here that are even or greater than 3? How many do I have? 4. Correct. You cannot count something, somebody twice. If it's been counted already, it's been counted. You don't count it again. And then again, you may see 2/3 out there. Okay, 2/3. All good with the or. It can be this or that, but I can't count something twice because now this is totally something new for many of you. Let me just clear my. All right, next up. Probability of getting a number greater than 3 given that it already landed on an even number. All right. First, symbols. Probability greater than 3. All right, everyone. The symbol for given is a vertical bar. That's the symbol for given. Okay, it's a vertical bar. Given that we already know it's even. All right. Every single problem we've done, it's always been out of 6, hasn't it? Been out of 6. When you have a given problem, it is not out of 6 anymore here. Here's why. What do we already know it landed on? Greater than 3, given it's already even. We already know the number's even. So now it's not out of 6. How many even numbers do we have? On the spinner, how many even numbers do we have? 3. So this is going to be out of 3 because listen, we already know the number's even. So it's not 6 of them, it's only going to be 3 of them, your choices, right? Does that make sense? All right, it's already given that number's even. And there's not 6 even numbers, there's only 3. So now, out of those 3 even numbers, how many now are greater than 3? How many of those even numbers we just highlighted are greater than 3? And it is 2 numbers. So it's a 2 out of 3. So watch out with these given probabilities because it's not out of the total anymore. It's out of whatever's been given. All right? 3 even numbers. Now we're going to do a lot more than that one. Any questions on the givens? Because I just flew through a lot here. Good? Great. All right. We're going to flip a coin and roll a 6-sided die now. We're going to flip a coin, roll a 6-sided die. First thing I want to do, and I encourage you to do this every time you can, write out all the possibilities. Because there's not many here. We can write out all the possibilities. Flipping a coin, what are your choices? Tails or heads? Rolling a die, 6 choices, right? So I could go, ready? Say I go ahead and I roll a 1, H1. I flip a head and I roll a 1. You guys keep going now. What are other possibilities I could do? Let's list them all out. There's not many. I could go what? Head and Roll a 2. It could land on head and 3, 4, 5, 6. Makes sense? All right, well, there's a couple of, we only did half the possibilities. What's the other it could be? What if I flipped a tail and landed on a 1, tail and a 2, tail and a 3, tail 4, tail 5, tail 6. Those are my only options, right? So write them all out if you can. Write them all out. How many options do I have? 12 options. So that's probably going to be my denominator on most of them, 12. What's the probability you get ahead? Okay, so look at all these options, count them up. We already said there's 12 options. So out of the 12, what's the probability a head came up? What's the probability a head came up? How many options contain head here, Chris?
1/2.
Well, do it till how'd you get to 1/2?
Flip the coin.
Okay, and then, but I'm looking 1, 2, 3, 4. Out of the 12, there's 6 that have a head, right? 6. Which then you get what?
6 over 12, which is 1/2.
Yeah, get 1/2. Yeah, just showing everyone where we got it from our list here. What's the probability you got a 2 and a tail? A tail and a 2 came up. 12 options. How many are a 2 and a 12? Both have to happen. Both have to happen. Sophie?
1.
Hey, there it is right there. Only one time that combo came up. Ooh, all right, ready? A 2 or a tail. Don't count twice, remember. Count them up for me, but don't count twice. If you've counted already, it's good. 2 or a tail. Could be a tail or it could be a 2. How many out of these 12 are a tail or 2? This is why you might become a little fishy. Kaylee, what do you got? 7. Good. Where'd the 7 come from, everyone? Ready? All of these count because they're tails, and that one counts because it's a 2. But you're not counting that one twice. All right? That one twice. All right. Okay. We're okay. Everyone's all right so far. All right. I don't want to lose you now. Remember our symbol there? That is given. So now we're thinking probably not going to be out of 12. What's the probability you get a tail when you know it's already a 2? Okay. Hey, ready? You already know it's a 2. How many options are you down to now? Not 12 anymore. How many options are up there that only have a 2 now? You only have 2 options. Yep. You only have 2 options. I know I already spun a 2. Out of those 2 options, how many contain a tail? Only 1. So you have a 1 out of 2 shots of getting a tail given it's a 2. We okay? The givens ones catch kids. All right, what about the next one? You would think it's 1/2, but let's see. What's the probability you get a 2 given it's a tail? Hey, it's a tail, or it's a tail. How many options? Not 12, but 6 options. Now you're down to 6 options right here. And of all these options, how many are going to be a 2? 1. So you have a 1 out of 6 with the given. Guys, ask away. With the given ones, just think when you're given, we have the given probability, it's probably not going to be out of the total. It's going to be out of a little bit less. Whew. How's it feeling, Henry? All right? Yeah. Okay, now we got to go to tables. All right, probability, given a table here. You guys, can you fill that in for me here? Fill in the totals. I think you guys have enough knowledge here. I don't need to help you. Fill in your totals here. It's a little naked right now. Fill it in. And the good thing about the tables, you filled them in right when you add them going up and down and left and right, and they come out to be the same total there. Okay, all good? Ready to answer some questions? All right, I'm going to take this one at a time with somebody. Henry, you're up first. Ready?
Sure.
Okay. What's the probability they will be both under 14 and it's got to happen at the same time? Both of them have to happen and 5 feet tall. So let's look at our table right now. You see the under 14.
Yeah.
Okay, right here, under 14, right? But at the same time, they need to be over 5 feet. So which one overlapped there? They had to be under 14 and over 5 feet. How many of them are there? 9. Everyone see where we got the 9 from? Has to be both. All right, well, the answer is just not 9 because it says probability. We talked earlier, it's got to be a fraction. Henry, 9 out of how many people here?
30.
Oh. What's our total?
100.
100. Yep, our total goes on the bottom. 9 out of 100. All good. Good job, Henry. Next up, Julia, here we go. What's the probability will be under 14? So look at the under 14. How many are under 14, Julia? 30. Yeah, everyone see total. 30. Got to make it into a fraction, though, out of how many people, Julia? 100. Good. And again, some of you guys say you might see 3/10 as an answer if it's multiple choice, because all I did was simplify. And you guys can do that in your calculator. Oh, boy. Here we go now. Here we go. Let's step up to the plate here. Julia, ready to roll? Good to have you here today. Okay, what's the probability they're over 5 feet or 14 years old? So let's start with the 5 feet. How many are 5 feet? According to the table, how many are over 5 feet tall? There's 67 of them, right, everybody? There's 67 out of how many, Julia? 100. All right, let's keep going. Plus, how many of them are over 14 years old? 70 out of 100, right? All right, something doesn't make sense. Because when I add these, what's going to happen? It's going to go over 100. Something's not right. You know what's right? Not right? We counted some people twice. All right. There's some people that are over 5 feet and also over 14 that we counted twice, and we can't do that. All right. So we need to subtract those people out that we counted twice. So, Juliana, going back to you, how many people in this table are over 5 feet and over 14 years old because we counted them twice? 58. Everybody see that? All right. We counted them once because they're over 5 feet. And we counted them a second time because they're over 14 years old. So we need to subtract out those 58 people. And go ahead when you're ready. 20. Okay, you got the reduced answer on your calculator, right? I got 79 over 100, which is what again? 29.
Yeah.
Did I do something wrong?
Probably not.
No, 137 minus 58. 67 plus 70 minus 58. Try it again.
79.
Yep. Over 100. Guys, are we okay with the or? You cannot count somebody twice. Plus, hey, guys, darn it! You know you did something wrong when you try to add up those things and it's over 100. Something must have been wrong. You can't have a probability bigger than 1. We've talked about that. All right, so if you're getting something bigger than 100, wait a second. I did something wrong. Oh, yeah, I counted 58 people twice, and I can't do that. All right, next up. All right, now the givens. Meredith, you got this. Ready to go? How are you today? Good? Good. All right. Find the probability of choosing a person over 5 feet. Ready, everybody? Given, there's that vertical bar, given that the person is over 14 years old. It's not out of 100 anymore. Because Meredith and I know that the person's already over 14 years old. We already know. We're given that the person is over 14 years old. So Meredith, we are not choosing out of 100 anymore. Look at your table. How many are over 14 years old? 70. 70 now. We know the kid is over 14 years old. So now, Meredith, out of these 70 kids here, how many are over 5 feet? There you go. And that's something totally new. Is everyone all right where the 70 came from? You already know they're over 14, so it's not out of 100, it's out of 70 now. And you only look out of the 70. Oh, questions, and then we're going to get to my favorite. It's being very sarcastic. You guys ever seen these before? I hate them. Hate's a strong word. Despise them. I do not like Venn diagrams at all. I had trouble. Even as a math teacher, I have trouble understanding Venn diagrams. So if I have trouble understanding them, how am I going to teach you that? That's my philosophy. You know what I love though? Love tables. Love looking at tables. So here's what I'm going to have you do every time. We're not going to deal with the Venn diagram. We're going to make it into a table. Okay, we're going to make it into a table because I can read tables much, much better than a Venn diagram. All right, so you ready for our table here? Oh, mustard and yogurt, good combo. Good combo. Anybody mustard people? Maybe sometimes on a hot dog. That's about it for me. Anybody put them on a ham sandwich? Mustard on a ham sandwich? I do that too. Yep. Anybody else mustard on anything else?
Not with yogurt.
Well, yeah, probably not. That would be vanilla yogurt. That's all I go. Vanilla.
I'm sorry.
I'm not a big ice cream. I will, but I'm not. And it has to be vanilla. That's it. No chocolate for me. Very, very rare though. But I'll do frozen yo. We will fro yo. All right, ready for the table. So up top, let's do yogurt. All right. So likes frozen yogurt. Oh, this is frozen yogurt. I didn't even know that. All right. So likes yogurt. Let's put likes yogurt on top. So if you put likes yogurt, you also have to have a column of no yogurt. Does not like yogurt. And then we're going to have a total. Oh, sorry.
Can we put on the right side?
I don't care what you do. I don't care how this table's filled. You fill it up however you want. All right, fill it up however you want. And then what do I got to put on the other side now? What's the other topping here? I got the yogurt, doesn't like yogurt. What else do we have? Mustard, here we go. Mustard, likes mustard. And then we got to have no mustard. And then a good old total column. Always have to have a total after. All right, ready to fill it in here with me as you guys. All right, ready? We got to put these numbers somewhere in the table and then fill in the rest of the table. Where's that 33 in the Venn diagram going to go? What's that 33 represent? Look where it is. And this is why I'm not a big fan of Venn diagrams. Tyler, what is it?
People that like yogurt and mustard.
Like both, right? So likes mustard, likes yogurt. 33 of those people. What's the 87?
They like yogurt, but not mustard.
Likes yogurt. No mustard, though, because that's separate. What's the 22, kids? What's the 22? That's going to be what? Likes mustard, but not yogurt. And then how about that 58 all by its lonesome out there?
They don't like any.
They don't like either one. No mustard, no yogurt. Yep, 58. Yep, and then go ahead, fill in the rest of the table now. This is why I'm not a big fan of Venn diagrams, but we can easily make it into a table we can understand. And then you know you did it right when the total matches up, going down and left to right. All right, who's up on the clock here first? Brady, ready, big dog?
Yep.
Your table good? 200 total people. All right, Brady. So we know it's out of 200. How many like frozen yogurt but do not like mustard according to the table? 87 out of the 200 people. Good start. Good start. 87. Easier to read a table. Now, could he have gotten that from the Venn diagram? Yeah, you sure you could have, but I like looking at the table much better, and probably you will too. All right, next up then, 1-9. Brennan, hello. Glad we're hearing from different people here. All right, Brennan, probability you like mustard. I don't care about I just want likes mustard. How many?
It's 55.
Okay.
Total.
55 out of
200.
200. Good. I just want you to like mustard. That was it. I didn't care about the yogurt part, so that's why we took the total. Good work, Kim. Good work. Who's up here? Julia, over to you now. All right, a little bit tougher one here because I've asked it in a little bit different way. Given that a randomly chosen person likes mustard. Hey, they already like mustard. Okay, so this is not out of 200 anymore. How many of them like mustard, Julia?
55.
So out of those 55, everyone see that? Given they like mustard already. Okay, now just look at those 55, Julia. How many of them also like frozen yogurt? There you go. Perfect. Okay, not out of 200. Only the people who like mustard. All right, there you go. Let's get it going. For numbers 1 through 4, I'd probably write out all the choices if you can to answer the question easier. Check them on your check. Hey, Chromebooks out too. Let's go. Chromebooks out so you know you're doing them right. We talked at the beginning of the class. We got to grind here right before break. Like it or not. I'm going to be coming around hovering. Ask me any questions that you have. How did I get that answer on the answer key?